All right. First of all, what we need to talk about is this little problem right here. Use differentiation to find the power series representation for 1 over 1 minus x squared. Okay, and so note number one, before we get started on this, is that what I know is I know 1 over 1 minus x equals this. That's the one we've been working with all along here. But what I have over there is not quite the same. Okay? And I guess one thing you could do is square all that, but if you're going to square this power series, you know, that's just infinitely sum, and then you square it, that's not going to help you much at all here. And so note number two is to note how this 1 over 1 minus x squared is related to 1 minus x. And it turns out, in the key here, the hint that they gave us, that I give you there in the problem, is that we're going to use differentiation to find this power series representation. And so here's the thing. Turns out if I differentiate 1 over 1 minus x, let's see what I get. The d dx of 1 over 1 minus x, well, that 1 over 1 minus x is, isn't that 1 minus x to the negative 1 power, which is, derivative would be chain rule. Bring down the power, subtract 1 from the power, multiply by the inside derivative, and we get negative 1 times positive 1 is negative 1 times negative 1 is positive 1. 1 times 1 minus x to the negative 2, which is 1 over 1 minus x squared, which is what I started with. Okay, so that's note number two. The derivative of this, which is this, derivative of this, which is this, is 1 over 1 minus x squared. Okay. All right, so how does that help me? Well, what I'm going to do then is I'm going to take, since the derivative of this equals that, if I do the derivative of this, I get what I'm wanting. Well, if I do the derivative of this, for my power series, I've also got to do the derivative of that side. Okay, and so as we just described there, this then becomes, the derivative of that is 1 over 1 minus x squared, from that work right there. The only thing left then is, for this, then this, the derivative of this side will be what that equals. Okay, so what about that? What is the derivative with respect to x of that? Wouldn't that just be the power rule there? We're doing the derivative with respect to x, so x is to the nth power, so wouldn't this be the sum of the n equals 0 to infinities? Bring down the power, and then subtract 1 from the power? There you go. That's the power series representation. It's a power series, so it's power series representation. Okay, let's try one more of those and show you how it works. Basically the same, but maybe another twist or two. Okay, here's another. Same problem. Use differentiation to find the power series representation, but this one's going to be x over 2 plus x squared, which looks vaguely like before. One thing to note here is I'm going to, the x, the thing I did the derivative of was the 2 plus x squared on the bottom. So I'm going to split this out to be this. And then I'm going to note the derivative of something that gives me that, basically. Okay. Well, a while ago we saw that the derivative of 1 over 1 minus x gave me 1 over 1 minus x squared. Okay, so what do you think to get, using a derivative, what do you think I'm going to do the derivative of to get 1 over 2 plus x squared? Probably, I might want to try the derivative of 1 over 2 plus x. Since the derivative of 1 over 1 minus x gave me that, then 1 over 2 plus x, let's see what that gives me as far as a derivative. All right? Well, that gives me, well, that would be the derivative of 2 plus x to the minus 1. So what's the derivative of that? Bring down the minus 1, 2 plus x, then subtract 1. And then the derivative of the inside would just be 1. All right, chain rule. We'll do chain rule. So we get something close. Wouldn't this just be this? Yeah, so we got close. It's not positive 1, it's negative 1 over 2 plus x squared, but that's going to be, we'll make the adjustment here, okay? All right, so here's what I'm going to do. I'm going to start now, so let's start with our same thing, because here's what I've got to do. I've got to start with this because I can convert that to a power series. 1 over 2 plus x as a power series. How am I going to convert it? Well, I need, my standard power series is this. So I need this to sort of resemble that. So let's see. Let's take that as factor off the 2 because I need the first number there to be 1. So I want to factor off a 2. So what does that make it? 1 plus x over 2. All right, then I need it 1 minus, so this is 1. Well, let's I don't need the 1 over, I don't need the 2 here, so let's factor off the 1/2. And then we'll make this 1 minus a negative x over 2. With me so far? Now I can change this over to the power series, can I? It's going to be 1/2 times, what is that as a power series? Well, instead of x, I have minus x over 2. So I'm going to put minus x over 2 in the place of x here. That'd be my power series. All right. Now, cleaning this up a little bit, let's go ahead and bring the 1/2, the 2 to the first power in, and break this up a little bit. This will be, what, negative 1 to the nth power, x to the nth power, and then 2 to the nth power. But if I bring that 2 to the 1 in, won't that be add 1 to that? Okay. So this right here is the power series representation of that. So let's write that down. So rewrite that. 1 over 2 plus x is the power series n equals 0 to infinity, negative 1 to the n, x to the n, over 2 to the n plus 1. Which is a good power series, but it's not what I want. I want the power series for this. Well, let's put 2 and 2 together here. Out of this, I know if I do the derivative of that, I get negative 1 over 2x squared. So let's do the derivative with respect to x of my 1 over 2 plus x. So I do the derivative this side. And let me split this out a little bit. Write the right side as this. Okay, so I know the derivative with respect to x of this is negative 1 over 2 plus x squared. Now what about the derivative of this? Well, I'm doing the derivative with respect to x, so the n stuff doesn't change, so it's still the sum of negative 1 to the n, 2 to the n plus 1. But then the derivative of that by power rule, bring down the power, subtract 1 to make the new power. Okay. All right, well, I'm almost there. That gives me the power series for that. I want the power series for that. So what do I need to do? Well, I need to multiply by an x. Well, first of all, I don't need it to be negative. So what am I going to do? I'm going to take that negative, basically multiply both sides by negative 1. And so that'll get me a positive 1. 2 plus x squared equals a negative. Now, that's negative 1 to the 1. So couldn't I bring that in to there? That'd be, this becomes this. Be negative 1 to the n plus 1 over 2 to the n plus 1 times n x to the n minus 1. Almost there. I need it to be x over 2 plus x squared. And so like I said, all I need to get to that is multiply both sides by x. And so that'll get me x over 2 plus x squared equals, now what will happen if I bring that x inside there? Well, that's x to the 1. And so I'm going to add 1 to that. So it'd be the series negative 1 to the n plus 1 over 2 to the n plus 1 times n x. And then this x to the 1, I'm going to add that to that. So I have n minus 1 plus 1. Isn't that just n? There you go. Huh?
Circle area on the left part of it, on the bottom.
Oh, thank you. Thank you. X over parentheses 2 plus x squared, thank you, equals the series n equals 0 to infinity. Negative 1 to the n plus 1 over 2 to the n plus 1 times n x to the n. All right. A little bit complicated, but yeah.
Are you surprised that I followed that?
No? Did good. All right. Got one more little problem here. And we'll be all good, I think. All right, so that one used differentiation. So we can use some differentiation to get a power series, and we can also use integration. Use integration to find the power series representation. of ln of 1 minus x. So I want to take ln of 1 minus x, and I want to write that as a power series, the sum of something.
Why are they just
Okay, well, of note here, again, we've got our 1, 1 minus x. And so what needs to be pointed out here is that if I take the integral, so, our 1 minus x is our standard series here that we do. Well, how in relation is 1 over 1 minus x related to ln of 1 minus x? Well, it turns out if I do the integral of 1 minus x of 1 over 1 minus x, let's look and see what happened. So a while ago we were doing the derivative of 1 over 1 minus x. Now let's see what we get if we do the integral of 1 over 1 minus x. Well, if I do the integral of 1 over 1 minus x, a little u substitution here, u equals 1 minus x. Du then would be minus 1 du. So du over minus 1 is dx. Or negative du is dx. What's the integral of minus 1 over u? It's ln, isn't it? Which is minus the ln of 1 minus x. Well, so close. Well, just multiply both sides by negative 1, and here's what we got. Okay. All right. So, back to our power series then. So we see that basically the integral of 1 over 1 minus x gives me the ln of minus x. Okay, so that's what I'm going to do here. What do I need to do here then to my power series? Well, I need to take the integral of both sides with respect to x dx. All right, so what we saw then is this. I mean, we can, whichever step you want here, but the integral that's minus the ln of 1 minus x. Now what about this? Well, it is a sum. It is a sum, and so each part of this, I'm going to do it with the, I can separate it out, but I can do the integral of each part of this, but each part of this, what is going to be the integral of that with respect to x? Just power rule antiderivative, right? X to the n plus 1, 1 over, then n plus 1 up front, and it's going to be the sum of all those, n equals 0 to infinity. The only Thing is, how am I going to get it to just ln? I'm going to multiply both sides by -1. This is equal to this. Isn't that a power series? There you go. We are